Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. We have been discussing quadratic equations in last few videos. The word problems also are solved in certain cases using quadratic equations. These word problems may be related with the numbers. The problems may be related with ages. It may be related with the work and time, or the speed, time, distance. Different kind of word problems can converge into a set of quadratic equations or a single quadratic equation, and the solution is done using the concept of quadratic equation. Let us take one example. The problem which is given here, it says the product of digits of a two-digit number is 6. On adding 9 to this number, the places of digits are interchanged. Find the number. Let's try understanding the problem first. Suppose the number is say 32, for example. Then the product of 3 and 2 will be 6. Okay. If the number is say 25, then the product will be equal to 2 into 5. Okay. Also, we know that in decimal number notation, any number is written, suppose 25 has been written or 26 has been written, then this is ones position and this is tens position, right? So if we have to break it, then the number can be written as 2 multiplied by 10, whatever is what digit as tens position, we multiply with 10, and whatever is at ones position, that is multiplied by 1, and that is how we get the number, which is in this case is equal to 26. Okay. So if a digit is written this way, if you have to find the exact number, you will have to multiply the digits at tens place with 10, the digits at units place with 1, and you add it and then you get the number. Okay. Now in this given context, let us assume that the numbers are, the digit is like this, that it is x and y. So at ones position it is y, and at tens position it is x. Okay. Then one thing from the problem statement is that the product of digits of a two-digit number is 6. It means x multiplied by y is equal to 6, right? Then it says on adding 9 to this number, what is the number? As I had explained you here, the number will be, we will take the digits at tens place and multiply with 10. We'll take digit at ones place and multiply with 1. So this is number 10x plus y is the number. Then the problem says, and on adding 9 to this number. So if I add 9 to this number, 10x plus y plus 9, then the places of the digits are interchanged. So if I add 9, how the digit becomes? The digit becomes like this. It becomes yx. Suppose if the digit was, just for example, if the digit was this, and if we add 9 to this, it changes position and it becomes like this. This is what the statement is. though exactly not this is the number. I'm just saying that if you add 9 to this number, the digits are interchanged. So for example, if it is 62, this will become 26. We really do not know what will be the number, but you see the interchange of the positions of the digits, right? So if adding 9 creates this kind of two-digit number, then this should be equal to digits at tens place. This is tens place, this is ones place. So 10 times y plus x times 1. That is how the new number will be when the digits are interchanged at ones and tens places. Correct? So you can then write 10x plus y plus 9 is equal to 10y plus x. If I collect all the digits on one side, I'll be getting 10x, and this comes this side, so 10x minus x, that will be 9x. And this comes this side, so it will be minus 9y plus 9, and that will be equal to 0. So if I divide uniformly by 9, then I'll get x minus y plus 1, and that will be equal to 0. And from this I can say then that y is equal to x plus 1. Correct? So we get these two equations. Now let's try putting y into this first equation. Then what happens? Using 2, equation 2, we can write x multiplied by y is equal to x plus 1, and that is equal to 6. So then we can write x square plus x, and this 6 we brought in the left side. So x square plus x minus 6, that becomes equal to 0. Now if I have to solve it, I can use either of the three methods which I have discussed. Because the numbers are smaller, we can try splitting the middle term. So then we can write that the numbers, or let's try quadratic equation formula this time. So if I compare that with ax square plus bx plus c equal to 0, then a is equal to 1. If I compare the standard equation with this equation, then a is equal to 1, b is equal to 1, c is equal to minus 6. So my discriminant will be equal to b square minus 4 into ac, and b square is 1 minus 4 into 1 into c, which is equal to minus 6. So this becomes 1 minus and minus becomes plus 24, which is equal to 25. Therefore, the solution of this equation, this quadratic equation, let me term it as a kind of equation 3. So that will be equal to minus b plus minus square root of d divided by 2 times a, which is equal to 1. And therefore, minus b, or let's write it as a, and then we can put the values directly. So minus b is minus of 1 plus minus square root of d, which is square root of 25, divided by 2 into a, which is equal to 1. And therefore we can write minus 1 plus minus 5 divided by 2. So therefore x can be either minus 1 plus 5 by 2, or it can be minus 1 minus 5 by 2, which leads to 4 divided by 2, which is equal to 2, or minus 6 divided by 2 is equal to minus 3. Now the digits cannot be negative. Digits are not numbers. Digits can't be negative. Therefore, you have to ignore this minus 3, and therefore x will be equal to 2. Now if x is equal to 2, then we can get y from equation 2 as 2 plus 1, that is 3. And therefore, the required digit will be xy, that is the correct number is 23, right? We can do the cross checking. If suppose we multiply these two digits, then x into y is equal to 2 into 3 is equal to 6. That satisfies the first condition, that the product of digits becoming 6. And then it is saying that adding 9 to this number. So if I add, this number is 23. So I add 9 to 23, thus becomes 32. So my original number was 23, and after adding it becomes 32. It means these two digits are interchanging positions, which is also correct. And therefore, this solution is correct, that x is 2, y is 3, and therefore number is 23. Okay. So with this example, you might have understood that how the word problems are solved using quadratic equation. You have to frame the word problem in terms of quadratic equation, phrase by phrase. Transition those word statements into algebraic form and form the equations, and then by substitution then you reach to a quadratic equation. When it is solved, you get the solution of the problem. Okay? Thank you.